Look up. Go ahead. Step out onto the porch of your fragile little rock, look past the smog and the satellites, and stare at those pristine pinpricks of silver. Beautiful, isn't it? A perfect, static map of the universe. It's a lie. A total, chronological hallucination. You aren't looking at a map of space. You're looking at a graveyard of time. Welcome back to the Space Traveler's Log. Today, we are stripping away the romantic poetry of the night sky and confronting 10 realities about stars that your brain is fundamentally unequipped to process. Before we fire up the engines, let's establish the baseline rules of this vessel. Fact 1. Every number we give you today is verified by teams of humans who don't get invited to parties. Fact 2. If your brain starts leaking out of your ears during Phase 4, there are complimentary paper towels under your seat. We are clearing for launch in 3, 2, 1. Clear your minds, because the sky you see right now doesn't actually exist. Let's begin with the most agonizing speed limit in the universe, 186,282 miles per second. The speed of light. We call it fast because it sounds fast when you're trying to outrun a parking ticket on Earth. But in the grand architecture of the cosmos, light is embarrassingly slow. It crawls. It drags its feet. Think about the sun. It's right there. You feel its warmth. But you aren't feeling the sun right now. You are feeling the sun from 8 minutes and 20 seconds ago. If the sun suddenly decided to spontaneously transform into a giant spacefaring hamster, you would blissfully continue tanning for nearly 8.5 minutes before the fluff arrived. But the sun is our next-door neighbor. Let's push out to the stars you actually see at night. Take Alpha Centauri, the closest stellar system to us. It sits 3 light-years away. That means the photons striking your retinas tonight left that star while you were still trying to figure out if TikTok was a fad or a permanent psychological condition. Now, let's look at Betelgeuse, that massive, angry red supergiant in the shoulder of Orion. Betelgeuse is roughly 640 light-years away. The light hitting your eyes at this exact microsecond left its surface around the year 1386. Think about that. While those photons were crossing the cold, empty vacuum of the interstellar void, humanity was busy fighting the 100 Years' War, inventing the printing press, discovering continents, and building the internet just so we could watch videos of cats falling off tables. Which brings us to anomaly number 2, the ghost stars. Because light takes so long to travel, looking at the night sky is like looking at a historical archive. Betelgeuse is at the very end of its life cycle. It is unstable. It is bloated. It could have gone supernova yesterday. It could have exploded 500 years ago. If it did, its brilliant dying scream is still traveling through the dark, rushing toward us at maximum speed, but it hasn't arrived yet. Right now, in this very second, you could be pointing your finger at a star that literally does not exist. You are admiring a ghost, a lingering visual echo of something that died before your ancestors even knew how to harvest potatoes. How does that make your Monday morning commute feel? Let us venture further out, away from the familiar ghosts, to look at the senior citizens of our cosmic neighborhood. This brings us to anomaly number 3, the Methuselah star, scientifically logged as HD 140283. We used to think the universe was a relatively comfortable 14 billion years old, but when astronomers pointed their instruments at this subgiant star, located just 190 light-years away in the constellation Libra, they ran into a massive mathematical crisis. Initial calculations suggested this star was over 16 billion years old. Now, unless our universe somehow managed to have a midlife crisis before it was actually born, that math is physically impossible. You cannot have a child older than the mother. Later, refined data brought the estimate down slightly to around 14.46 billion years, which still awkwardly sits right on the messy edge of the Big Bang itself. Methuselah is composed almost entirely of hydrogen and helium, containing virtually no heavy metals. It is a pristine, walking fossil from the dawn of creation, a star that watched the dark universe wake up, which transitions us cleanly into anomaly number 4, the newborn paradox. While Methuselah is quietly decaying out in deep space, new stars are being assembled right now inside stellar nurseries like the Orion Nebula. But here is the thing nobody tells you about a newborn star. It spends its infancy trying to blow itself apart. When a massive cloud of interstellar gas begins to collapse under its own gravity, it forms a protostar. It isn't a real star yet. It doesn't have nuclear fusion running in its core. Instead, it grows by feeding on a surrounding disk of gas and dust. As it drags matter inward, magnetic fields twist tightly into cosmic ropes, shooting colossal jets of superheated plasma millions of miles out into space from its poles. Imagine a human baby that, instead of crying, occasionally fires heavy artillery cannons out of its ears. This brings us to anomaly number 5, the hidden energy crisis. When that protostar is collapsing, before nuclear fusion ever ignites, it actually radiates an unbelievable amount of energy. This is called Kelvin-Helmholtz contraction. As gravity crushes the giant cloud into a dense sphere, potential energy is converted directly into thermal energy. The heat generated by the sheer weight of gravity crushing that gas is so intense that the baby protostar shines brighter than it ever will during its adult life. It is glowing fiercely in the infrared spectrum, screaming its way into existence out of the dark. It is only when the core reaches a staggering 15 million degrees Celsius that hydrogen atoms finally slam together to form helium. Nuclear fusion ignites, the outward pressure stabilizes against gravity, and the star officially punches its time card to join the main sequence, which leads us to anomaly number 6. Stars are incredibly bad at using their fuel. You might think a massive, hypergiant star like VY Canis Majoris, which is large enough to swallow our entire solar system up to Saturn, would live forever because it has so much hydrogen. It's completely the opposite. Massive stars are cosmic sports cars. They burn through their fuel at an absolute reckless pace. A hypergiant star might burn out and explode in a measly 10 million years. Meanwhile, a tiny, pathetic little red dwarf star, smaller than our sun and barely glowing, sips its hydrogen so slowly that it can live for trillions of years. In fact, not a single red dwarf star born since the beginning of the universe has ever died yet. Every single one ever created is still out there, quietly ticking away in the dark. Now let us zoom out entirely and look at anomaly number 7, the illusion of proximity. When you look at the night sky, stars look like a crowded swarm of bees. They seem tightly packed, jostling for space in a glowing cosmic ocean. This is the ultimate perspective trick. If our sun were reduced to the size of a tiny grain of sand, the next closest star, Alpha Centauri, would be sitting over 20 miles away. The space between stars is not crowded. It is a mind-numbing, isolating, terrifyingly empty desert. If two giant galaxies collide with each other, containing hundreds of billions of stars passing straight through one another, the mathematical probability of even a single star physically hitting another star is effectively zero. They are ships passing in an ocean of nothingness, but don't let that emptiness fool you into thinking space is peaceful. This brings us to anomaly number 8. The Runaway Outcasts. Most stars sit comfortably inside their galaxies, orbiting the center in a nice, predictable wheel. But occasionally, a binary star system drifts just a little too close to the supermassive black hole at the center of our galaxy. The immense gravity of the black hole tears the system apart. It swallows one star whole and uses its kinetic energy to catapult the second star away like a gravitational slingshot. These are hypervelocity stars. They are traveling at over 2 million miles per second. Fast enough to completely break free from the Milky Way's gravity. They are currently screaming out into the intergalactic void, destined to spend eternity completely alone in the absolute blackness between galaxies. Which brings us to anomaly number 9. Iron is the ultimate cosmic poison. A star survives by converting elements, moving up the periodic table as it ages. Hydrogen becomes helium, helium becomes carbon, carbon becomes oxygen. Each step releases energy, pushing back against the crushing weight of gravity. But eventually, highly massive stars reach iron, and iron is a thermodynamic dead end. Fusing iron doesn't release energy, it absorbs it. The second a star tries to fuse iron in its core, the energy furnace shuts off instantly, the support beams are cut. In a fraction of a second, gravity wins, and the entire multi-million-mile structure of the star collapses inward at a quarter of the speed of light, triggering a cataclysmic supernova explosion. Iron is the exact moment a star realizes it is mortal. Finally, anomaly number 10. The irony of the dark sky. If the universe is infinitely large and contains an infinite number of stars, then no matter which direction you look in the night sky, your line of sight should eventually hit a star. The entire sky should be blindingly, completely white. This is Olber's paradox. The reason the night sky is black is because the universe is expanding, stretching the light away from us, and because the universe has a definitive beginning. Light from the furthest stars simply hasn't had enough time to reach us yet. The darkness of the night sky isn't proof that space is empty. It is proof that the universe has a past. So, the next time you step out onto your porch and look up at those silver pinpricks, remember what you are truly witnessing. You are looking at a living archive of ancient history, populated by burning giants, screaming newborns, and glowing ghosts that vanished long before you arrived. We drew lines between the stars and called them constellations. The universe just called it distance. Log entry closed. See you on the next ascent.